Hello everyone, this is Mr. Warren Sibadong, and I will be presenting this resource material which is focused on EIGRP, in which we will be implementing some of its features, practical scenario in an enterprise network. We can also use this material or video material to test our students' EIGRP knowledge and skills. So to start, first I think I have to introduce to you, and so that you will be familiar with our current topology. Our topology here, so we have two locations, the branch office and the main headquarters. And in the main headquarters, we have two networks. So we have a network C for our server on the server side, and also net B, which is on the client side. And we have also network A, which is in the branch office. And these two sites are connected via three one links. The frame relay with the CIR 512 assumed to be, and we have a T1 line with a CIR 1.54 Mbps, and also the MPLS to have a 2 Mbps CIR. Now, we will be presenting to our students three scenarios, problems, in which we will try to collect their ideas and their solutions for each scenario that we will be presenting. And also, initially, our topology is configured with all the necessary IP addressing and also the basic EIGP routing related configurations. It's already in place and it's already working. The one links is already done, and in fact, these two routers are already an EIGRP here. So to check that out, we can use our command, the show IP EIGRP neighbor. Check if they are already here. So in fact, it's already. And these three links, these two routers seeing each other. And to start, so let's go to our first scenario, in which we have here a network administrator adds the new network, the net A, which is in the branch office, and made already necessary changes its configuration related to EIGRP. However, net A still cannot communicate with net B and net C. So what exactly caused this problem, and what would be the configuration solutions to this? Now, if you take a look at our topologies, you will notice that we have net A and net B, which is coming from the same subnet block coming from a class A of 10. Now, to check if they don't have really connectivity, so perhaps we can ping these PCs here. So this PC3 its IP address is 10.10.20.20, and our FTP server here is 192.168.1.20. So we can try to ping it from PC1 using our ping command, and again, as what I have said, there's no connection. So it says here that destination host unreachable, and for our 192.168.1.20, again, it's no connection at all. So it's a request timeout. So how are you going to solve this problem? Now, again, this scenario number one is the problem is actually related to automatic summarization, which is by default is enabled, and we know that this configuration is not appropriate for a discontiguous subnet. So if you're going to look at back our topology rather, we have net A and net B, which is coming from the same block, but in between is another block which is a class B. So this makes our topology now a discontiguous network. Thus we have discontiguous subnet. So to solve this problem, again, as what I have said, we're again trying to help our students and let them think on their ideas and their opinions on the topology. This is again, this material is one way to test their skills. Now, let's go back to the solution. The only solution here is, of course, to disable the automatic summarization in all these three routers. And our commands should be the no auto summary. So let's first check its routing table, by the way. Show white route. So you will notice that in the branch office, we don't have any entry for net B, which is 10.10.20. So we only have here the 10.10.10.0. So this is because that the main office router are sending or updating the branch office router with a summary address of 10.0.0.0. So that's why we don't have any entry for the 10.10.20.0 here. So to let the main office router send the exact subnet of net B, and as well as the main office router to be able to receive the exact subnet for net A, which is 10.10.10, because in the main headquarters router, you will notice also that we don't have any entry for the net A block, which is the 10.10.10.0. So again, this is because of automatic summarization, which is enabled. So again, to solve this issue, so we just simply go to the router configuration mode, EIGRP 200, because I'm using here autonomous system 200, and then issue the command no auto summary. So you do this to all of these three routers. Again, you go to the router mode, and then no auto summary, and then lastly our internal router, we need to issue that same command no auto summary. So let's check if the expected entries is now coming out in its routing table. Let's try in the internal router. So its routing table should provide us an entry for the 10, and in fact it's there. So the 10.10.10.0, and for the branch office, we should also be able to have the exact subnet for the 10.10.20, which is our network B, and of course we already have for network C. So to check for the connectivity again, so let's check. So expected that we should have now a connection. In fact, there is already. And for the server side, so we have this expected reply. So that solved the first scenario. Again, for the next scenario, we have here the network administrator was tasked to use all the connection path for both sides of the enterprise location when sending data traffic on either side. So the administrator is expected to use all the 3-1 links. Once either side of the network send data, router should use all the 3 paths. So what should be the solution to this, and what should be the configurations that we're going to make? Now let's go back to our topology and let's check the topology table, EIGRP topology table of our branch office router using this command. Of course, you know this already, the show IP IGP table, and you will notice that going to net P 10.20, you have 3 routes because we had 3-1 links, as well as in net C we have also 3-1 links. But as you notice that our feasible distance is that is 1,290,240, which is actually the path going to our MPLS cloud. So this would mean that the best route is going to the impedance cloud, and you can verify this one in the routing table of a router, in which it shows only a single entry, a single path going to the other side from the branch office router. It sees only a single path. We choose only one best path, and that is going to or out to the MPLS network. So to use the other one links such as T1 and the frame relay cloud, then the solution for this is, of course, we have we need to change, our variance. Remember that the problem here is that by default EIGRP router is using equal cost load balancing. So the reason for this, because we have by default a variance of 1, and with a variance of 1, this will only allow equal cost load balancing. Remember that variance is used, this can be used as a multiplier for our feasible distance, so that we can implement, if we're going to change this one, we can implement an unequal cost load balancing. So the solution for our scenario is, of course, we need to implement an equal cost load balancing. It's because these three different paths have different metrics, and we need to include these two other paths in our IP routing table. And to do that, so let's go back to our topology table, and you will notice that we have here a feasible distance of 1 million, but the two other paths have a metric of 2 million, and the other is 5 million. So to include these two other paths, so we need to change the variance, which is a multiplier for this, and that we will get a value that makes these two metrics below or less than that value, so that we could tell our router to make these two other paths and consider it also as the best path. So if we're going to calculate that, again, our feasible distance is equal to 1,290,000. So that's 1,290,000 that is 240. Okay, so 240. And what should be the appropriate variance for this? Now the appropriate variance for this is 5. It's because this will give us, we're just going to use our calculator here. So that's 1,290,240 then times 5. This will give us 6 million. If you're going to make it 4, this will only provide us 4. This will provide us a 5,160,000. And to check again our topology table, the highest metric we have here is 5,500,000, in which this value is less than that. So that's why the next value, that variance value that we can apply is 5, because it will give us 6 million. So this will allow now, or tell our router to include also this path as the best path. So to do that, your configuration will be, just add this variance of 5. Sorry, it's not 3, but it's 5. Sorry, that should be 5, it's not 3. And You do that to all of the routers. You're just going to the router configuration mode again, 200, and then variance of 5. On the other routers, you do that also, a variance of 5. And lastly, in our internal router, we should have router EIGRP 200 of variance of 5. So in this case, let's go back to our branch office router. So as expected, we should have now additional entries in our routing table, in which going to our net B, which is the 10.20, so you'll see that we have now included the 2 other paths. So in this case, once the branch office router sends data to any of this network, it will use these 3 other paths. So again, that solves our scenario number 2. Again, our variance should be 5 in this case. So let's move on to our last scenario, in which here the administrator was tasked to make internal router send a summary address for the 192.168.0.0 networks to other routers in the enterprise. What configuration is necessary and which router should be we're going to make this configuration made. So our solution here, of course, we can implement manual summarization. So since automatic summarization is already disabled here, then we can enter this command, so in which this one serves as a summary for all our networks in the internal router. So let's try to check its routing table. So we try to look at its routing table. So you will find here all the 192.168 networks, that is from 0 to 7/24. So if you're going to summarize this, this will give us a prefix of slash that is 16, that's 21, so that's a prefix of 21. Okay, prefix of 21. So this will give us a 248 subnet mask. And of course, we're going to enter this one in our internal router in this passive node 01, where it will send out updates. So to do this, so you have the interface FA01, and you have the IP summary address EIGRP 200, and then 192.168.0.0 space 255.255.248.0, and then enter. So you will notice that in our main router, so we should have now changes in its routing table, and you will notice that we have now here our, that is a 21 entry, so which is received from FE01, which is actually coming from here. And in the internal router, you will find some changes of its routing table, in which we have here another entry, which is a summary, the manually created summary route, no? And of course, lastly, in our branch office, there are also changes in its routing table, in which you will have now a single entry for that supernet route, and that is the 192.168.0.0/21. So that ends this video material. and I hope that this one helps you um, introduce this material to your students, and which we can also gauge and scale their understanding and their knowledge and skills in the EIGRP. So thank you so much.